This lesson, we're going to talk about basic counting principle using the set information we just learned from the previous sections. Here, a few definitions we wanted to go over before we actually go into the example. The first one is addition principle. Addition principle is for any two set, A and B. If we wanted to find the number of A union B, then we will do number of set A plus number of set B, and then subtract number of set A intersection B. The reason you're doing a subtraction is because when you're adding these two elements and these two sets, you're using the overlapping elements twice. So that's why you're going to subtract that one out, right? So for example, if you had one here, one there, if you're adding those two, you're using one twice. That's why you're going to subtract the intersection one time, so that you will only use the intersection once. But if it's a disjoint set, so what's the disjoint set? The first case is assuming that we have joint set. So that's why overlapping area you're using twice if you're including set A once and then set B, right? Then you're using intersections area twice. So that's why you're subtracting one. But when you have a disjoint set, disjoint means they don't have any overlapping. That's why you just add those number of elements from each set. And we have multiplication principle. What's the multiplication principle? If two operations are performed in order, then the outcome is going to be found by multiplying it, right? So multiplicate, that's why multiplying it. That's why it's a multiplication principle. But if operation is more than 2, then you keep multiplying that operations, number of the operations. And all that you should be able to understand better when we go into examples. So example 1, this problem is mentioning survey of the business. There is 750 total employee have health insurance, and then 640 offer the dental insurance, and 250 offer health insurance and dental insurance. They wanted to know how many offers their employees health insurance or dental insurance. So don't forget the information it's given. Let me write it. What's the information is given? They're giving you, the first information is number of the health insurance by itself was 750. And then number of dental insurance itself was 640. And then the third information, which is 280, offer health insurance and dental insurance altogether, is going to be number of health insurance and dental altogether, right? So don't forget they're using n, which means that's going to be intersection of those two. It's going to be 280. What are they asking you to find? It's a how many offers employ health insurance or. So together, but this time or. Or means unions of it. So you're looking for now number of health insurance, unions, dental insurance. Remember from the previously, what was the formula for it? Formula was number of first set plus number of the second set minus number of the intersections, right? In order to find the unions. So that's going to be 750 plus 640, and make sure, because by adding those two sets, you're using intersection twice, so you need to subtract that one intersections. This will give you about 1,110. This means 1,110 business offers health insurance or dental insurance. Example 2, it's a city has 2 daily newspaper. This is the 2 daily newspaper company. And then informed that information was obtained from a survey of 100 city residents. 35 people subscribe the Sentinel, and 60 subscribe Journal, and 20 subscribe both newspaper. And they wanted to know if we'd be able to figure out all this. So the best way to do this, I'm going to use the information we learned from the previous sections, which is the set. So I'm going to draw a Venn diagram. And in order to draw Venn diagrams, I need to have the letter that represent these 2 newspapers. So let's use the Sentinel, use the variable S, and then Journal, let's use the variable J. And when we draw the Venn diagrams, we will have 2 sets. First one is the Sentinel, and the other one is Journal. And this is the union set. And it's a 100 city residents, so your union is going to be 100, right? So remember, when we're building the Venn diagram, we start from inside. So what's the inside? Here, intersection of those 2. Intersection of those 2 say that 20 subscribe both newspaper, right? So that's going to be 20 here. And then it's a 60 subscribe the Journal. So this circle, total of this circle should be 60. So when you take this 20 off, you will have 40. So only 40 people actually subscribe only the Journal. Same thing. It's a 35 people subscribe Sentinel. So this whole circle should be 35, and you used 20 already. So 35 minus 20, you will have 15. And then when you add them up and subtract from 100, that's not 100, that's 1,000, right? 100. You're adding 15, 20, and 40. And then subtract from 100, you get 25. So that will be what the people that do not subscribe any of those 2 journals, right? With that Venn diagram, we should be able to answer these questions. It's a how many people subscribe the Sentinel but not to the Journal. So Central but not the Journal will be this, which is 15. And then the second one is say how many subscribe to the Journal but not to the Sentinel, right? So that's going to be this. So that will be 40. C is asking how many do not subscribe to either paper. That's going to be 25. And the last question is asking, organize this information in a table. Well, I already gave you as a Venn diagrams, right? So this is going to be what T is. Now let's look at the next problem, example 3. The retail store stocks windbreaker jacker in small, medium, large, and extra large size and are available with blue or red. What are the combined choice and how many combination choice are there? So this is something I can show you. Tree diagrams. So tree diagram, it starts with what's the first choice? First choice was the size, right? So we'll have small. Let me use it with black. Small, and then we have mediums, and we have large, and then we have extra large. And both, all this size will have either blue or red, right? Blue or red. Blue and red. So you could have either small blue, small red. That's the two options. And you have medium blue or medium red, large blue or large red. So this is all the options you could have. And how many of them? Look like you have 8. This one was the smaller size of the examples. But what about if you have like 100 choices for the one, and then you have another, 10 choices for the second? You will not be able to draw this chart. So in that case, what do? We can just use the formulas we did. Remember, if it's happening in order, then you do the multiplications, right? So it will be first choice of 4 times the second choice, which is blue and red, will give you 8. So your solution is going to be 8 possible outcomes. Either way you will get 8, right? What about the next example? It say many college and university use computer for testing. Suppose that test is to consider 5 questions. So you have 5 questions. Computer solve 5 questions for the first task questions. So for the first questions, question 1, you have 5 options. You have 8 options for the second questions, 6 options for the third, 5 options for fourth, and 10 for fifth. And they wanted to know how many different questions tasks can the computer selected, right? So the way that I will think with this problem is you have 5 questions. Then first questions, you have 5 ways. Second, you have 8. Third, 6. Fourth, 5. And fifth, 10. And this is by order, right? Because when students are solving the problems, they will do by order. So you should be able to use multiplication principle. So you will do 5 for the first, 8, 6, 5, 10 options. When you multiply all that, it will give you about 12,000 different tests. so that students will not get the same test. And that's how you're going to use multiplication principle to these types of word problems. Let's try one more. What about how many 3 letters code are possible using the first 8 letter of the alphabet if no letter can be repeated? Will be the first. So if we have a 3 letter code, then you are using only 8 and you cannot repeat it. So if I use 1 out of 8 for the first, I have 8 ways. And then 8 different letters that I can pick, right? Because I cannot repeat it, I cannot use the same letter. It means that I only have 7 choice for the second letter, and then I will be 6 choice on the third letters. So in order to find the possible code words is going to be 8 times 7 times 6, which is going to be 336 possible. For the first case. The second case, it's a letter can repeat it, right? So if the letter can repeat it, it will be all 8, right? So when you multiply 8 3 times, that's going to be 8 cubed. That will give you 521. So if letter can be repeated, you have more possible outcomes. What about C? So this one, it's a adjunction letter can not be the same, right? It means my first letter will have 8 options. Since the next one cannot be the same, so I will have only 7 options. But this one cannot be the same as the second one, but can be the same as the first one, right? So that means I only cannot pick this one number, so you still have 7 options. So when you multiply that, it will be 8 times 7 times 7, so you get 392 possible code words. So the third one is saying that you cannot have the same number right next to each other, right? So that's why the third one will have still the 7 options, because this is only numbers that you cannot, or letter that you cannot pick, right? So that's going to be just one number and one letter I cannot pick out of 8. That's why it's the 7. So basically, this is how we can use the multiplication principles to find the outcomes.